recording. Kabloop. All right. So we are not doing this section. No, we are doing this homework problem. But we don't have a formula for it, so I have to reference back to this. And we still don't have a formula. So this was designed for a 2x2, which apparently was great up until the last question. And then we have to do some extra work, which is so sad. But we can do that. At least I'm going to attempt it. You know, this is stumpedprofessor.com, so here we go. And if I get stumped, then I delete it. So there you go. Yay. I think we can get this done. So obviously everyone in here is in our linear algebra class, so we should be fine. Oh, I'm sorry, engineers. Oh, you're engineering too. Sad. Oh, really? Oh, well, I like you now. But you got a job right now. You got a job too, so that didn't count. It doesn't count anymore. You had a job. You have a job. Part-time, okay. There it is. There it is. And I can technically say two full-time jobs, right? Yeah, teacher and parent. Okay, yeah. Moving on. But it is like that. So yeah, find Jacobian, but this is a 3x3 thingy. I was making a joke because what we need to do is the determinant of a 3x3 Jacobian, which is like really hectic crazy. So let's see if I can try to figure out at least how to get this started here, and then we'll work backwards and around it and stuff. So notice this is x in terms of u. So then I'm going to do x in terms of u, and I got x in terms of v, x in terms of v, and then they're also using w. So, you know, going along with the pattern, I would have x in terms of w in the top, right? And then we just keep going. So y in terms of u, y in terms of v, y in terms of w, z u, z v, c w. Okay. Instead of trying to go and do it generally, which I could probably do it right now with the formula. But I want to see if I could just pop in some numbers and maybe it'll be way easier. But we'll do this determinant together. It'll be fun. Oh yeah, this will be no problem at all. Y'all are gonna have so much easy fun here, okay? So actually no, you're gonna have a terrible time. It's gonna be the worst thing ever. But it's gonna be fine. It's gonna be fine. So yeah, let's talk for a second. Let's pause. The second one is easier than the first one because I'm gonna get numbers and then I could just do determinant in Desmos matrix and be done. Would you like me to show you that one and then I can go back and do the hard one in A? Okay, thanks, I guess. You're like, actually, no, Chad. I want you to do the hard one first. So I'm going to get this one wrong. That's what you always need to do on the homework, right? Oh, look, they gave you the formula. Look, why'd you even ask me? There's your formula. Duh! No, I'm playing. That is so mean, isn't it? Okay. So let's do this thing. I'm going to do the bottom, and then we'll go back up to the top. It won't be too bad. The x, I'm going to find the derivative in terms of u. What would I get? Just 5. Just 5. You get me? Because it's x in terms of u. Yeah, and then what's x in terms of v? Yes, and then w. So far things are looking up and looking good. Okay. Y in terms of u in terms of v. Yep. And then in terms of w. And then again 0, 0 for this one. Derivative. Yeah, 1/3. Yeah. Yep. To find the determinant of this, I think all we need to do is multiply the diagonals together, and then we're done. That was really silly of me there. I believe that's all I have to do. So 5 times 3 times 1/3 is equal to, yes, exactly. So that is an easy one. But how do I normally do this if I didn't, like if I had a lot more numbers than just the diagonals? Let me go to Desmos Matrix and show you a cool little thing here. Sadly, none of our classes teach determinants anymore, but it used to be a thing. So I need to do a 3x3. You totally remember this from your college algebra days. Correct, but we're not doing that. And that's the thing. Like we didn't teach you to do this instead. So there you go. So we just did a determinant, and there's your answer. Cool? For part B. Now I didn't want to do part A because I know that I'm going to get a variable in the end, and you saw the answer as well. I can't do this with variables, so what you're seeing here is completely useless in just a second. It was fun for a moment though. I'm waiting for just a second. Yes, on the final. Oh, but this is for exam 2. I don't think I have Jacobians on there. We're gonna review it and make sure, but I'm pretty sure I didn't have room for them. And if I did, they're like simple. Yeah. If they're on there. And I have to go and check. I can't remember if I even had room for them. So you good? Can I at least change over to my homework question, Ryan? Good, thank you. So no, you're great. You're great. So let's go and try to do the same thing now for this one. I mean, it's really not too much more difficult. I'm going to just do it side by side because, like, this is part B, I guess. Now this will be part A. I want the derivative of this thing in terms of u. Very good. 4 cosine v. And then in terms of v, perfect. You got it exactly right. Negative 4u sine of v. I'm going to run out of room. But in terms of w, what would it be? Yes. Bloop. Cool. That 0 right there is helping us. If I get just one more 0, this really is all going to come into like pretty work. So we're getting really close. Here we go. This one in terms of u. Cool. And then in terms of v, that works. And in terms of w, now our determinant will be easy to compute right now. I'll show you the co-minors thingy, which y'all know. But y'all are going to learn now. Even you. Yes, the co-minors thing. So this is making it super easy here in just a second. So last one, in terms of x. Yep, 0, 0, and then finally. So let's talk about co-minors and whatever they're called. I think they're called co-minors. Do y'all remember? Cofactors. Isn't there a minor or major in there? Oh. And then we have like the adjoint or something like that. I don't know. It's like, that's been a long time, Chad. But it's on the final. Anyway, so yeah, I know. So what we can do, for those of y'all that don't know linear algebra, and even though for those that y'all do know, I'm going to pick a row or a column that I like, and I'm going to pick one with zeros because it makes it way easier. And I'm going to basically multiply it by whatever I'm not using in its row or column. So let me show you. If I select this 0 for the front number, I then have to like select this, and this will be the matrix beside it. And so I would do this dude here, and this dude here, and a 0 and a 0. But like 0 times anything is 0. So like that was all pointless. Okay, I just wanted to show you the process here. The next one, minus sign this time. I'm picking that as, let me use a different color. Use a different color. Okay, I'm going to pick this one now. And then again, we're doing this. What did I not cross through was blah, 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 blah. It doesn't matter because what's in the front is a 0, goes away. And then we got a plus sign now. The plus sign is saying we're going to pick the 5. So again, I'm doing this kind of thing. So 5 in the front. What we're not crossing through would be this stuff. So this is going to be the actual math. We'll actually have math for once here. Let me kind of real quick make sure I'm doing this right. 4 cosine v, negative 4u sine v, 4 sine v, 4u cosine v. All right, awesome. Can you take a determinant of a 2 by 2? Technically, because you have a formula for that one. It's the regular Jacobian formula, essentially. Or if you wanted to be fancy, you could do it how we do in linear. Oh, yeah. Yeah. Big man on campus. So 4 cosine of v times 4u cosine of v. Now my 4's and u's are looking kind of similar here. Minus sign a negative 4u sine v, and then a 4 sine v. That's it. Yeah, 5 times all that stuff. Simplifying a little bit. Plus sign on this, maybe. A little bit more math. So I have 4 times 4 is 16 times 5 is 80. Oh, just by chance. So then I got cosine. I got a u cosine squared v, and then 2 negatives will make a positive u sine squared v. And you know that I could factor a u out now. And of course, what's cosine squared and sine squared? There it is. We got it. So the math side wasn't too bad. And you got to learn about determinants of 3 by 3s. So that's fun. And y'all got to relearn. Yay. Or, well, review at least. They're professionals at this point. So, but are y'all okay with this? Especially y'all 3. Good? Please do. Please do. Right here, you would do just the same thing 3 times. Yes. Yep. Exactly right. Yeah, it's not too bad. It's just, it gets in the way. But yeah, the zeros make it so much nicer. Yay. Oh, right. This guy right here? This one. Okay, so y'all are going to remind me. I think they're called that's the minor, isn't it? The co-minors? Right. Like that's what I'm saying. These things are the minors. Yeah, cofactor minor. No. Am I flipping it? Oh. I don't remember. Me neither. So you're saying this is the minor, this is the cofactor. Nah, it's cool enough. It's good enough. The stupid names. We don't need. Sorry, I meant names. Where did the minus sign come from? Well, every one of these 3 by 3 determinants has hidden symbols that you don't see. And I chose this one. So positive, negative, positive. Yes. In fact, this is a big cross product-y thingy. Yes. Very good. There's just a minus sometimes, and there's a plus sometimes, and that's just what it is. Yes. Cool. Okay, what is this one called? I'm playing. I'm just stopping. I should know these things. I'm the teacher. Yeah. Well, I mean, it's not a big deal. You just do the math, right? Okay. Give me another one in. Oh, okay. Bloop. Oh. Oh, I love this. I want to do it. It's Stump the Professor Day. I don't like how it's too squished right there. Okay, so we got u and v is equal to that. Oh, I remember doing this one. I would love to do it again. So I'm gonna. Are y'all good with this? Can I erase my determinant stuff? You good? Good. Okay. Perfect. Perfect. All good. Okay. There we go. Up. All right. Yeah. So double integral of all this stuff. The main thing that I'm looking at is the u and v, and this is why we're in the Jacobian section anyways, is to do some substitution stuff to make it easier. Okay, close enough. Okay, so u is equal to x plus 3y, and v is equal to y minus x. Do I see those somewhere here? Like this? And I want to do this here, or flippy flop, either way. But I have to do a Jacobian times all this stuff, and then we have different limits here. So this is a good prototype for what we're wanting, but we still have a lot of things to fill in. And so let's start working on that side of things. So the Jacobian is the, well, I guess I could just do the actual formula now. It was x sub u, y sub v minus x sub v times y sub u. Do I have x equals blah? Not exactly. So we have to rearrange these to get x equals, y equals, that kind of thing. I'm going to do this. So now I have x is equal to y minus v. And then I can plug that in here. So u is equal to y minus v plus 3y. Combine my y's. That's a 4. That's a u. Move this over, divide by the 4, and I got y is equal to u plus v all over 4. I'm going to plug that in. This is technically 4 over 4, so I believe I get a negative 3v over 4. Okay. Pause on that. In fact, I can now just zoom in on this stuff. Y'all know these Jacobians, they take forever. Many head nods. I think I counted about 15 head nods.
Yeah, just from one person.
Yes. Yes, from one person. Thank you for clarification on the online folks. Oh, yes. I can hold. Correct. Yeah, because that was technically 4 over 4, and then subtract. Yeah, exactly. You got it. So x in terms of u, what would be my number? That's a u, by the way. 1 over 4. And v in terms of y in terms of v. Perfect. Minus sign. X in terms of v. And then finally, this guy in terms of u. 2 negatives make a positive, so we're going to get 1/16 plus 3/16 is equal to 1. Yep, 1/4. So that's my Jacobian. I can now basically rewrite this thing and say there's a 1/4 in the front. And now we need to redo our limits. So far, are y'all okay with this? Yay. I'll wait for a second though, because this is like the next phase. Good, good, good. All right, here we go then. So looking back, we have this stuff here. I want to rewrite it. So I have x is equal to 0, x is equal to a half, y is equal to, wait, wrong. Thank you. Y equals 0, y equals a half. X is equal to y, and then x is equal to 2. Thank you. So this is my original, but I want to be able to like toss them in and stuff. You see, I have my x's and y's here. Don't I just like plug it in and solve essentially? Are you sure about that? Because you're the one that asked me.
Oh, yeah, I must have tried to follow along, see if I messed up somewhere in my notes.
I can't remember this because there's so many little steps for these. I think what I did is I'm just tossing, when it says y equals, I've just tossed it in. Like just substitute, right? So then u plus v over 4 is equal to 0, but then u plus v over 4 also equals a half. Now from here, I'm gathering something that u is equal to negative v, I guess. And from here, I don't feel like I'm doing the right thing. I feel like I'm doing something wrong. Give me a second here. Yeah, no. We're doing okay. I think we're gonna do okay. So I got these two guys here, which I can start to solve and do other things here. Remember, I'm getting like two sets of numbers. X is equal to y, so that would mean my u plus v over 4 is equal to u minus 3v over 4. Cancel the 4's out. U plus v is equal to u minus 3v. The u's will cancel. So then I've got v is equal to 0, essentially, don't I? Okay, so like that's a hard set number, which is fine. We're going to use that here in a second. Last one, let's plug it in over there and see if I might not even need to do this, but we'll do it anyways. U minus 3v all over 4. 2 minus 3 times u plus v all over 4. Now I need to solve this dude. I need a common denominator, so this will be an 8. This 3 will go up in the numerator here. So u minus 3v all over 4 is equal to 8 minus 3u minus 3v all over 4. The 4's are going to cancel, the 3v's are going to cancel. When I move this over, I got 4u is equal to 8, so u is equal to 2. I'm getting actual numbers, which is good. I think with these, I can go back and try to find the other guys.
What I did with that one is, I don't know if it's the right way, is I would just put it to set numbers for
Mm-hmm.
make it where
Correct. Yep. So then I would have u is equal to negative v, v equals negative u. So then basically I get u is equal to 0 and u is equal to 2, because like if I plugged in a 0. And then on the other side, I have v equals 0 and v equals negative 2. I think so. Am I wrong? Or is it negative somewhere else? No? Oh, you know what? No, no. I don't think so. I think it's going to be whole numbers like this. I'm pretty confident about that. Real quick, I don't like these exactly. I'm really close though. I think I assumed something real too fast. Okay, if I plug in a 0 here, I'll get u equals 0. Is that a correct statement? So u equals 0, v equals 0, right? They're kind of like a pair. If I plug in a u equals 2, then v must equal, okay, so that's like a pair in a way. If I plug in the 0 here, then u is equal to 2. I just didn't write it though. I wrote 0. I don't have any more room. When I plug in a 2 right here, then v equals 0. I think that's the same. Oh, no. When v equals 0 here, then u is equal to 2. I already did that. So there we are. We got these numbers. It seems like to me that we have u is between 0 and 2, and v is between 0 and negative 2, essentially. Is it gonna be a formula? I'm like a function. I don't know. I don't think so. They did it.
They did the equations and I still got it wrong. So I'm not sure if I did something, but I worked it out several times and got the same answer.
Okay. Hold on. We're getting really close. If I do 0, 0, and then I did 2, negative 2, and then I did 2, 0, then yeah, I would have a triangle. Okay, so then I would have an equation. Okay, I got it. We're going to try that. So I'm going to scroll and we're going to do this thing now, okay? Essentially, if I'm going to do dv du, that's what I want is dv du. Then I'm going to do, the bottom would be just a negative x, but a negative u essentially. So negative u all the way to 0 is at the top, and this is 0 to 2. And I want to see what my answer is going to be. Is that what you did?
At the top I got another equation of 3 minus that might be where I messed up.
And I'm trying Desmos graphing, of course, because I want to see what their answer is and compare. And so it probably is like divide by pi or a square root or something. Right now we're just seeing, do I have the right concept? And so that's what they got. Now let's type that. Okay, so that was pretty wild. Got it. You're right. Yep. So we got it. Whatever this was, this guy here is actually the way to do it. And then we'll just integrate. That one's easy to integrate. I'm pretty sure we did this problem before. But you're right about the equation. Let me go back to the reason why there is just an equation here. It's because we have the 3 dots. I wanted to plug in a 0. So I plug in a 0, I have to get a 0 for the other guy, check mark. I plug in a 0 for this one, and so the other one's got to be a 2. Right? I plug in the 2 into the top. Therefore, I have to get a negative 2. I plug in the 2 into the bottom, I have to get a 0. And it's like I duplicated the bottom one twice. So what? So I have two dots there. When you look at the graph between them, it has to be a triangle, not a rectangle. Good? Okay. Yes.
I got a fourth equation of 3 minus u where you have your 0 up at the top of the first integral. I think that's where I probably messed up.
Okay. Yes, I can. I can go wherever you like. All good. Crazy times.
Trying to stump the professor, but I got it this time.
I would say so. Yes, because sometimes you'll get 4 points, which is very traditional. Then you just basically have a rectangle, and it's very simple. So this time we didn't. We had a triangle, which made it a little different than normal. Give me something else, or I'll go in and keep doing, regular math. Have we only been doing problems today?
I think we've only done the 2 more problems.
Only 2, and it took 35 minutes. All well and fine. So I went and did the next section, and it actually turned out really easy. So, but that's up to y'all. Let's give it a 5 count. 5, 4, 3, 2. There's so much paper moving right now. anything to escape what we're going to be doing. You do?
I don't know how hard it is, but I have a star next to the problem.
It is a stump. It stumped a professor every day.
That's from 15.5 to question 14.
Okay. 15.5, 14, number 14. I'm okay with whatever. No, I already did it. Oh, did I do this like yesterday or something? What did it end up being?
You wouldn't have just guessed. You were trying to figure out, and then you're like, oh, well, let's just do decimal way. And you saw about 4 equals, part.
Oh,
And then like, so let's try 4 5.
but I didn't do the integral.
You did.
Oh, I did.
I think it was just okay.
All right, cool. Yeah, watch my video, bro. I'm just playing. It is. It is. Mm. Can't remember. Or did I not finish this one?
One that we switched to polar in cylinder format,
Mm-hmm.
and then had to try software. I don't think we finished the integral.
Oh, the by hand integral?
Yeah.
Oh, well, your homework was to find out how to do it. Oh, and we went to ChatGPT after class,
Yes.
and it went crazy on us. Yeah. So I'm gonna look for this problem and make sure it's not on the exam. Until then, just some Desmos would be fine. Right. Right. The answer, like once we got the integral, just toss it in, right? Just toss it in. But yeah, we don't have to do all that. Oh well, then I'm not gonna record that, but. 5, 4, 3, 2. Come on, it's easy math going forward. Are you for sure? You name it, I got to do it. You paid me to do it. We did that one too. That was fun. That was so fun. Yeah, that was one of my favorites right there. Oh yeah, easy. We can do that. My audio quality's been pretty good recently. See? Bro, it's working here too. You see? Let's make it 3. See, it's working. It's working. It's not too bad. So I don't even remember how to do this stuff, but I think we can do it. They're wanting to change my x to be x equals, right? Isn't that what we were doing previously just a second ago?
They want you to find your x equals yada yada and then y equals yada yada.
Yeah. Yada yada. Cool. Let's do it then. So we have u is equal to x minus y, and v is equal to 2x plus y. To solve for x, I'm going to move it over. And so then, oh, no. So x is equal to u plus y. And then I can plug it in right there. So then v is equal to 2 times u, 2 times y, and then another y. So I got 2u plus 3y. To solve, I move over and divide. So that would be v minus 2u all over 3. And then I can plug that back in for my x. U plus all that stuff. Common denominator, so this will be a 3 over 3. When you subtract it, it should just be u plus v all over 3. And that's my those are my answers. At least I hope so. Cool. And this guy. Cool. Oh, and then I have to find your Jacobian. But I'll pause for a second, just make sure. Are you good with that?
Yeah.
Solving, I guess resolving, unsolving, something like that. The Jacobian is xu yv minus xv yu. And so this one would be a 1/3. This one here would be a 1/3. 1/3, and then negative 2/3. Because these are two negatives, they make a positive. So we're going to have 3/9, which ends up just being a 1/3. There we go. Yeah. Correct. Like that other one we did, yes. Yep. Yada yada. Yep. And look, it's still working. Bloop.
Was it Jet expanded to the point where it's just recording just all the way down so you know your thing's going the entire time?
5, 4, 3, 2. What? Are you kidding? That's a boob moment. You like D? Okay, so what I would do, these are X's and Y's, and I would plug them in here and here and there and there. So 0, 0, I get a 0. 1, 1, I get a 0. And then this guy here, I would get a 3. So I got basically 0 and 3 for my U. So that's my X value, essentially. So 0 and 3, 0 and 3. So essentially it's D or B. Well, it's not D, so it must be B. But then we do go over to the V's. 0, 0, plug them in, we get a 0. 1, 1, we plug them in, we get a 3. And then plug these guys in, I think we get a 0 again. So yeah, 0 and 3 again. We're just kind of getting all our little numbers. And basically we got a whole lot of 0s and 3s. No negatives. Good? Right. And most of the time it's a rectangle anyways. So 5, 4, 3, 2, 1. All right. Yes. No, not that. Gosh, man. We already did Jacobian so much. And I can come back to them next week. I won't mind. I'm happy to get stumped. And then I just delete it. So surfaces and area. I gotta say, this section was it was deceiving to me. It was deceiving. So they want to talk about this U and V substitution, I guess you would say. But really, the whole big thing here, blah 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 blah, right here, not even right there. I would say right here. That's what the whole section's about. And by area, they mean surface area. I can't spell surface area, but there you go. So surface area, how do you find it? There's your formula. Super easy. Cool with that, yes? There it is. Well, let's talk about that. I love the similarities. So if I had find the arc length, like from here to here, right? But then what if I made that into a 3D surface in a way? So I'm doing this, but then like it keeps going and it keeps going. What you made is not just find the length, but now find the area. So it's just an extension. It's an extra dimension, right? Because I'm going from one integral to two integrals now, and that's the only difference. So exactly right. That was an excellent connection that you made. Yes. So yeah, arc length, same formula. That was funny actually. Okay, so it's all about surface area. That's what the problems are about. So what is this hoo-ha? And then they do it again. And then we move on and actually find the surface area, which if you look at this section as if find the surface area with that formula, easy every time. Oh my gosh, I got the whole thing done in about 5 minutes. Okay, so I want to do that. But why are these problems up front? What do they mean? They mean nothing. They mean nothing to you right now. What they mean is for the next section after it. I don't know why they included them here, but you know me, I got to include them with the section that they're in, I suppose. So concept-wise, there's not much going on here, but I will want to do it with you just because it's fun. Those are fun questions. They're not hard. So they say ignore everything that we've been talking about, and let's just seek something completely new in your life, and then you'll never see it again. So they say we need to do a parameterization, blah, 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 for these two things. Normally what we do is R in terms of T, right? And we make in terms of T, everything's in terms of the T. We do a single integral, blah, 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 everything's happy, okay? We can't do that this time. They're saying surface area, therefore we need to use two variables. And you could use S and T, but then S looks like a 5. And so they said, nah, let's use U and V because that one looks like a 4. So whatever. U and V, S and T, same ideas. Okie dokie. You can even, if you really wanted to, you could do phi and theta. It wouldn't matter. We're just doing two random numbers, random variables that will work. Yeah, don't write those down. You don't need those. So what are we looking at here is a sphere and a cone, okay? What options do we have that would make this thing work? What is the similarities that you're seeing here? Again, remember, these are my I's, these are my J's, and these are my K's. Haven't you seen this before? I will wait. Okay, I'll rewrite what I just said. Okay, I'll rewrite what I just had. I had a U and a V, I had an S and a T. What were the other letters? Huh. Phi and theta? Huh. Yes. How about you give me an English name? Yes, that's perfect. Spherical coordinates. Yes. Let me rewrite my formulas for this stuff, right? We had x was rho, and I'm trying to remember this stuff. It was sine of phi cosine of theta. Y was rho sine of phi sine of theta, and then Z was rho cosine of phi. Wow, doesn't that look familiar? Right? And all of them look like that, don't they? If there is any differences, it's maybe in like a small little sine or a cosine or something. So the concept here is they're saying this is spherical coordinates. So far, so good. Now we have a sphere. It's okay, so the cap cut from a sphere by a cone. You know what? That sounds a lot like one of the labs we just did. So we have a sphere and a cone. We've done something just like that. And what did we do on our lab? Spherical coordinates, right? Spherical triple integral. So then which one of these makes sense then? See, this is what we got. You like A? I don't like A. I don't like A. Right here, see how there's two signs for my X? So yeah, let's say that again. B or D, okay. I like that. So yeah, B has a cosine, and that has a cosine. So those are good. That's legit. This still has the cosine over here. And those are both sines. So which one is the phi and which one is the theta? The u is the theta, and this is the phi because right here is my phi, isn't it? For the z, that's always a phi right there. That's the only one distinguishing between them. Or you can go back and say my cosine and sine are the ones that are changing in this particular case, so that must be my theta dude. Now, is theta supposed to go from 0 to pi over 6? Or is theta supposed to go from 0 to 2 pi? Exactly right. Flash the answer. Cool, right? So what we're doing here is we're decoding, okay? Now, I have a question for you. Would you like to create that out of scratch? It's not that bad. Look at that thing. It's spherical coordinates. Nah. Copy paste, bro. Copy paste. Yeah, this one was an easy one. Okay. Last question is a concept question. Where did they get the pi over 6 from? Yeah, why? Where did this guy come from? He's correct, so heck yeah, it is right there. Yep. That's that. This is actually a slope right here, and so I'm saying the slope of my cone is basically 30 degrees, essentially. Well, 30 from the top, I think. So that would be 60 degrees total. Blah blah blah. Cool. Okay. All right. This is a you do now. Or at least you just got to look at it. Tell me which one looks right. I'll wait for a minute. Do you see it? This one's an easy one too. Call it out. Give me a letter. A, B, C, or D. C. I don't know either. I haven't looked. You like B? You like B? I don't know. I haven't looked. But what can I say is that all of these here are saying that x is equal to u and y equals. And if those are the cases, then I go and look, oh my goodness, that looks the same thing. Right? So far, we're just making it like, well, I got to make up a u and a v. X and y. And it's like, yeah, all right, fine. So when I'm looking at this guy here, I'm saying x is 3 and then x is 4. So I'm saying my u is going between 3 and 4. 3 and 4. And then and this guy. If I said z equals 0 and I plug it in, wouldn't I get plus or minus 3, essentially? Plus or minus 3, plus or minus 3. Well, hold on. What's wrong? What's the difference between them? Oh, look, there's a u right there.
So is z supposed to be defined that y is this one, since we have z equals 9? No, it's just where they're placed. It tells you x, y, and z. Okay.
My hints, since they gave them to me, was just u and v.
Yeah, so it just being x and y.
Mm-hmm.
I wasn't sure if the z is what helped determine that y was v.
I hope that eventually we'll be able to create these on our own. This was a very simple one. The other one wasn't too bad. In the end, you're looking for formulas that you've used before, and you're just making 3 variables into 2 variables, essentially. So here we had x, y, and z. Now you're just going to go uv. Okay? The last one we had rho, phi, and theta, right? So now I just have u and v, or, phi and theta. So that's kind of the concept. Cool? And you'll never see it again. So let's do, we only got 3 minutes. I want to show you how this works. It's such an easy problem, and then we'll be leaving in a minute, okay? So find the surface area. Let me give you the formula again. So it's double integral of the f sub x squared, the f sub y squared, plus the 1 dy dx, okay? I did this one so crudely, and yet it still worked. It was just hilarious to see. Very rough approximations. So I need to have this x, fy. What they're saying is zx, zy, essentially. Okay, I'm going to do a little hand wave that y'all can't see online. Essentially. So if I were to say that was a z that we're starting with, yeah, do we have a formula that will work like that? Exactly right. We have to solve for it first. That's one of the keys. So then I need to find z. I need to find zx. I need to find zy. So z sub x. Perfect. Z sub y. Beautiful. So then I say double integral of double integral of negative 2x squared, negative 2y squared, and then plus the 1 dy dx. Almost. I need the limits and then we can Desmos. So I need to find the limits that'll make this thing work. Remember, in this particular case, we're in rectangular form. I wanted to do polar because it looks like a polar would be so much easier. Good luck with that. I tried it a couple times and I wasn't getting anything great, so I'm just going to stick with rectangular. Hello. Did you get a t-shirt, by the way? No? What? Did you order a t-shirt? Okay, we'll talk about it later. I'm being recorded, okay, Gwen? Come on, you're talking so much. I'm playing. I'm playing. Yes. There it is. Once you do that, what do you get? When you plug that in?
Then you can solve for y by moving it over, so you get 20 minus x squared in a square root, and then you would have that first as the limit.
I was wanting a shape.
Oh,
Circle! Exactly right. We got a circle here. So yeah, but you're right that we need to solve. I'm going to move my x over. I got my y. So plus or minus the square root of 20 minus x squared. And that's what I'm going to start putting here. Okay. And this is very similar to that one plane equation you were talking about, and I was saying dimensional reduction.
very similar here. What if I removed my y and then I had to solve for x? What would I get? What would I do? There it is, plus or minus square root 20. And so that's how I'm getting my limits on this. Desmos, and we're done. No way.
Well, one thing I'm curious about, Chad, is since we have they're both the same in the bottom as they are on the top, just -4, can we multiply it by 2 as well? Or at least in the first integral.
Yes, I think that's okay here. In fact, you can probably get away with doing like a multiply by 4.
Yeah, that's what I was thinking.
Yeah, if you do 4 times something. I'm not going to risk it right now, but that is, I would say that would work in this particular case. Everything's symmetric. It looks really good. But you know me, I'm just going to brute force this stuff. Oh, here we go. And then square root of 4x squared plus 4y squared, and then always a plus 1, which I want to ask about, like where the plus 1 came from. Go ahead. The z, what's the derivative of z in terms of z or whatever is 1, right? It's kind of a weird kind of situation. Exactly. Okay. I can't remember if I just divide by pi or something. Oh yeah, there it is. So it's a pi answer, 364 pi over 3 over 3. Flash the answer, and there we got it. No problem. So yeah. Cool. So we're out of time. We're done. I just wanted to like show you that this would work. What I would do personally at this point would do the 4 times something and then probably go to polar, but we could do that next time. Or we just say Desmos. But you can see, like in a funny way, look at this is the work that I did. This is the work that I did. There is none because I just looked at it and said, oh yeah, I know how to do this. Okay, and that's how I did it for this one too. And that's how I did it for this one too. And that one I actually did some work. But go ahead. Correct. And this is on the final, so I'm not worried about it. Okay, thank you guys.